What is data science, and how does it differ from traditional analytics? Data science involves extracting insights and knowledge from data using various techniques and tools, including statistics, machine learning, and domain knowledge. It goes beyond traditional analytics by encompassing a broader range of skills and processes, including data collection, cleaning, exploration, predictive modeling, and the use of advanced algorithms. Explain the steps involved in the data science project life cycle. The data science project life cycle typically involves the following steps: understanding the problem, define the problem and set project goals, data collection, gather relevant data for analysis, data cleaning and preprocessing, handle missing values, outliers, and prepare the data for analysis. Exploratory data analysis, either understand the data's characteristics and patterns. Feature engineering, create new features or modify existing ones to improve model performance. Model selection and training, choose appropriate models and train them on the data. Model evaluation and validation, assess model performance using metrics and validation techniques. Deployment, integrate the model into the business process or product. Monitoring and maintenance, continuously monitor the model's performance and update as needed. What is the CRISP DM model, and how is it used in data science projects? CRISP DM, Cross-Industry Standard Process for Data Mining, is a widely used framework in data science projects. It consists of 6 stages: business understanding, data preparation, modeling, evaluation, and deployment. Data scientists follow these stages iteratively to develop and deploy models effectively while aligning with business objectives. What is the difference between supervised and unsupervised learning? Can you provide examples of each? Supervised learning, it involves training a model using labeled data, where the algorithm learns to map input data to corresponding output labels. Examples: classification, e.g., spam detection; regression, e.g., predicting house prices. Unsupervised learning, here, the model learns patterns and structures from unlabeled data without predefined output labels. Examples: clustering, e.g., customer segmentation; association, e.g., market basket analysis. Question: what is overfitting in the context of machine learning, and how can it be avoided? Answer: overfitting occurs when a model learns the noise in the training data instead of the underlying patterns. It performs well on the training data but poorly on unseen data. Techniques to avoid overfitting include cross-validation, early stopping during model training, using simpler models, and regularization. Question: explain the bias-variance trade-off in machine learning. Answer: the bias-variance trade-off is the balance between a model's ability to capture underlying patterns, low bias, and its sensitivity to variations in the training data, low variance. A model with high bias might oversimplify the problem, while high variance can cause overfitting. Achieving the right balance is crucial for optimal model performance. Question: what are some common preprocessing techniques used in data cleaning and preparation? Answer: common preprocessing techniques include handling missing values, outlier detection, and handling data normalization or standardization, encoding categorical variables, and feature scaling. Question: what is regularization in machine learning, and why is it important? Answer: regularization is a technique used to prevent overfitting by adding a penalty term to the model's loss function, discouraging overly complex models. It helps in creating models that generalize well to unseen data. Question: what is the difference between batch gradient descent and stochastic gradient descent? Answer: batch gradient descent updates the model's parameters using the entire training dataset in one go. It is computationally expensive for large datasets. Stochastic gradient descent (SGD) updates the model's parameters using only one randomly selected training sample at a time. It's computationally less expensive but can have high variance in parameter updates. Question: explain the purpose and usage of cross-validation in machine learning. Answer: cross-validation is used to evaluate a model's performance by dividing the dataset into training and validation sets iteratively. Question: what is feature engineering, and why is it important in machine learning? Answer: feature engineering involves creating new features or modifying existing ones to improve a model's performance. It helps the model better capture patterns and relationships in the data, leading to more accurate predictions. Question: describe the difference between type I and type 2 errors. Answer: type I error, false positive, rejecting a true null hypothesis, i.e., claiming there is an effect or relationship when there isn't. Type 2 error, false negative, failing to reject a false null hypothesis, i.e., claiming no effect or relationship when there actually is one. Question: what is A/B testing, and how is it used in data analysis? Answer: A/B testing is a method to compare two versions, A and B, of something, e.g., a web page, to determine which performs better. It is used to make data-driven decisions by analyzing how different variables impact user behavior and outcomes. Question: explain the concept of p-value in statistics. Answer: the p-value is the probability of obtaining test results at least as extreme as the ones observed during the test, assuming the null hypothesis is true. It helps in assessing the significance of the observed effect or relationship. Question: what is the central limit theorem, and why is it important in statistics? Answer: the central limit theorem states that the sampling distribution of the sample mean approaches a normal distribution as the sample size increases, regardless of the population distribution. It's crucial because it allows for the use of inferential statistics and hypothesis testing in various scenarios. Question: what are the assumptions of linear regression? Answer: linear regression assumptions include linearity, relationship between variables is linear, independence of errors, homoscedasticity, constant variance of errors, and normality of errors. Question: explain the differences between time series analysis and cross-sectional analysis. Answer: time series analysis involves analyzing data collected or recorded over time to identify trends, patterns, and make forecasts. Cross-sectional analysis involves analyzing data collected at a single point in time to understand relationships and patterns across different entities or subjects. Question: what is dimensionality reduction, and why is it important in data analysis? Answer: dimensionality reduction involves reducing the number of features or variables in a dataset while retaining essential information. It's important to simplify models, improve computational efficiency, and avoid the curse of dimensionality. Question: discuss the differences between bagging and boosting in ensemble learning. Answer: bagging, bootstrap aggregating, involves training multiple models independently on random subsets of the training data and averaging their predictions to improve performance and reduce overfitting. Boosting trains weak learners sequentially, with each model correcting the errors of the previous ones. Boosting focuses more on misclassified instances. Question: what is the difference between classification and regression in machine learning? Answer: classification predicts discrete labels or categories, e.g., spam, not spam.